Hi everyone, welcome back. So Leetcode daily question today is find the longest substring containing vowels in even counts. So we are given a string S. We have to return the size of the longest substring where each vowel occurs an even number of times. So the string contains only lowercase letters and vowels are A, E, I, O, U. So how to do this? The basic brute force approach is we find every substring. We put two loops for each substring, and after that we count the number of vowels in that, and then we check if all the vowels are occurring even number of times or not. So that shall go n cube, but our time complexity can go only to n log n. So that won't work. Other further optimization shall be we create a array for each index for vowels for vowel count, and for we keep on adding from first to the last index vowels which are occurring and keep that array for each index. So we pre-compute the values of all the vowels till any index, and after that for any subarray we can directly subtract. For left to right we can directly subtract the number of times the vowel is appearing in the right array and the number of times the vowel is appearing in the left array. So that will give us the vowel count. So this has reduced the time complexity from n cube to n square because we do not need to count for each subarray, right? But still it is out of bound. We still need to optimize it. So what shall be the optimal approach? So one thing we know is we need to keep the vowel count, and we need even number of times for each vowel to appear. So why not keep vowel as 0 and 1? 0 means even number of times, 1 means odd number of times. So the same thing we shall be doing. We shall be storing vowels as a bit in a number. So if A comes one number of times, the A bit will be 1. If E comes one number of times, E will be 1. If E comes two number of times, the bit will change to 0. So if it comes even number of times, the bit is 0. If it comes odd number of times, the bit is 1. So this is okay for storing. But now how to know that what shall be the longest substring? So suppose we are moving forward from first to the last character, and we have this A comes one time at index 1, at index 0, right? And after some characters we again get the same mask, means A is odd number of times at index I. So for this to be even number of times, for this to be the longest substring with even number of times, we need to remove A, right? So where shall we find that A? If we search this mask and find that A was coming previously, this mask was coming previously at 0 index. So the length of longest substring shall be I minus current index minus the first index of that mask. So this shall be our longest substring, right? So this approach we shall be using to find the longest substring. For each mask we shall be storing it. If that mask is already present, we shall just calculate the longest substring because that is the required mask that we need to make it even number of vowels, to make even number of vowels. So one thing we have understood. Now how to do this? For each character we need to change the bit of that position. So we need to convert vowels to bit position. So A we are storing at bit 0, E we are storing at bit 1, I at bit 2, O at bit 3, and 0 at bit 4. If it is another constant, then we shall returning -1 to know that it is a constant. Now for each mask, we shall be storing its index, and we need to optimize the search time. So we have used a hash map which shall store the mask, Bitmask, and its index, first occurring index. Now the answer is initially 0 because the longest substring possible is 0. Mask is initially 0. Now we put this mask with no element as -1 because when we subtract it, it shall give us the length, because if we get a constant, only a constant b, so the mask shall be 0, and 0 minus minus 1 gives the length 1, correct? So we have started it with -1 length, -1. Now we put a loop on the string, we take the character, and from our function we get its position. So if it is a constant, what we need to do, we just need to calculate the maximum substring possible. For that, we will calculate math.max answer and current index minus, what was the formula, current index minus map.get mask, the first time where the mask was occurring. For the constant, mask remains changed. There is no change in the bit mask because there is no vowel. So it is sure that that mask will be present previously in our hash map. We just need to get its first index to subtract it and get the longest substring. So we have calculated the answer and we are just continue for the constant case. Otherwise, we have got a vowel, correct? So we need to change the mask first. We need to modify its bit. So if E is coming, so the position, so if suppose E is coming, so E is one position, so we need to change the bit at that position. How will we change the bit? We are just XORing the position with our mask, because XOR changes 1 to 0 and 0 to 1. So we are pushing 1 to that many places for that many bit and XORing our mask with that. So the P position bit will get changed. If it is 0, it will turn 1. If it is 1, it will turn 0. So our new mask is ready. Now we just need to check if we already have that mask. We will get our answer. So answer is equal to math.max answer comma I minus the first index that it was coming, so mask was appearing. So this will give us the answer. Otherwise we shall put the new mask in our map because it is coming first time. So we are putting a mask in map at the ith index. We have found this mask. So at last our answer will be with us in answer variable. So we shall just return that. So this was the analog n approach for this question. I hope you guys would have got the solution. Thanks for watching the video. Have fun. Bye.